So welcome again. It's been a while since I've posted any videos. It's because I've been so busy. And the last video I posted, um, there was no talking in it, right? Because I had limited time to do it. So I'm looking at the May 2019 question 2. And the first part of the question, part A, we have 3p squared multiplied by 4p to the power 5. Right? So 3p squared multiplied by 4p to the power 5. Alright, if we have to multiply this, what we do, we multiply the constants first. So we take 3 and we multiply by 4, and we're going to get 12. And then p squared multiplied by p to the power 5, right, is equal to p to the power 2 plus 5, because I'm applying the laws of indices here. So this is 12p to the power 7, right? So that's the answer for part 1. For part 2, as this one here, we have 3x over 4y cubed divided by 21x squared divided by 21x squared over 20y squared. So we can write this as 3x over 4y cube. Right? We're going to change the division sign to multiply, and we're going to invert this. So this becomes 20y squared all over 21x squared. Right? So it's as if we divide in two fractions here. Now, from here now, there are some things that can cancel each other, right? So for example, this 4 can go into 20 5 times, and this 3 can go into 21 7 times. So let's look at this now. So we have 5xy squared as a numerator, and then we have 7x squared y cube, right? Now we can still simplify this further, because this x can go into x squared x times, and y squared can go into y cube y times. So the final answer is going to be 5 over 7xy, right? So in order to do this question, you need to remember the laws of indices, and the two laws that we use for this question would be multiplication. So if we have a to the power m multiplied by a to the power n, then we add indices, so this becomes m plus n. If we are dividing, so a to the m divided by a to the n, we must subtract, right? So that's the answer for part A. Let's look at part B now. So in part B now, they want us to solve this equation, right? Now, when students see an equation like this, they get confused and they're not sure what to do. So this is an equation, right? Notice we have an equal sign in this. And the first thing we should do is to add the two fractions on the left-hand side, right? So when you're adding two fractions, what you need to do is to find the LCM of 7x minus 1 and x, right? So that will be 7x minus 1 multiplied by x, right? We're going to put this line here. Now we're going to ask ourselves, we're going to say this x multiplied by 7x minus 1, we're going to divide it by 7x minus 1, and that'll give us x. So let me show you in the working column what we're doing here. So we're saying x 7x minus 1 all over 7x minus 1. Alright, so this will cancel with this, and we end up with x. And then we're going to take this x, right, and multiply it by 3. So on top here, we're going to get 3x. You're going to write back your sign, right? So a plus sign here. Now the next thing we're going to say is x into 7x minus 1. And we're going to divide that by this x here. Alright? So this will cancel with this, and we end up with 7x minus 1. So what you're going to put here now will be, I'm going to take this and multiply by 1. So you're going to get 7x minus 1, right? And that is equal to 0. So all you're doing here is you are adding two algebraic fractions, right? I have a video on this that you can check out if you're not sure what I'm doing. So on the numerator now we're going to have 3x plus 7x, which would give me 10x, and we have minus 1. And at the bottom we have x into 7x minus 1. And all of that is equal to 0. So basically you have an algebraic fraction that is equal to 0, and we need to solve for x. So in order for this equation to be equal to 0, my numerator has to be equal to 0. So therefore 10x minus 1 is equal to 0. So therefore 10x is equal to 1, and therefore x is equal to 1 over 10, right? So therefore x is equal to 1/10. Now for this part now, when a number x is multiplied by 2, the result is squared to give a new number y. So the new number y is simply equal to, so the first thing they said we have a number x, we're multiplying by 2. So if you multiply by 2, it'll be 2x. And then they said the result is squared to give a number y. So we need to square all of this, right? So that's the answer for part 1. The next part, part 2, determine the two values of x which satisfy the equation y is equal to x and the one you had in part 1. So the first equation you had in part 1 was this: y is equal to 2x squared, and they give you another equation which is y is equal to x, right? So essentially what they are asking you to do is to solve a pair of simultaneous equations, right? That's essentially what they're doing. So this first equation, right, can be written as y is equal to 4x squared, right? When you square 2x all squared, you're going to get 4x squared. So this is my equation 1, and that is my equation 2. So we're solving a simultaneous equation. So all we're going to do, since we have y equal to 4x squared and y is equal to x, we can see that 4x squared is equal to x, right? And then we're going to solve for x. So this is 4x squared minus x is equal to 0. And this is a quadratic equation that we're going to solve, and we're going to solve it by factorizing. So we're going to put, the only thing common here is x. So this will be 4x minus 1 is equal to 0, right? And we can say either x is equal to 0, that is one solution, or 4x minus 1 is equal to 0, therefore 4x is equal to 1, therefore x is equal to a quarter, right? So my two solutions are x is equal to 0 and x is equal to a quarter, okay?